Okay, in this screencast I'm going to talk about using trigonometric identities. And I love this topic because it's kind of like solving a puzzle. So before we talk about using trig identities, let's go over the main trig identities that you're going to be dealing with. The first ones are called the reciprocal identities. And you already know these. The sine of x is equal to 1 over the cosecant of x and vice versa. The cosine of x is equal to 1 over the secant of x and vice versa. And the tangent of x is equal to 1 over the cotangent of x. So we use those to get things out from underneath denominators. Quotient identities. There are two of these. The tangent of x can be rewritten as the sine of x over the cosine of x. And the cotangent of x is the same thing as the cosine of x over the sine of x. The advantage of that is that we can rewrite tangent and cotangent completely in terms of sine and cosine. Okay, we've got just a couple more categories. Pythagorean identities. We've already covered this, but remember that sine squared of x plus cosine squared of x equals 1. And if I divide everything by sine squared, I get 1 plus cotangent squared of x equals cosecant squared of x. If I take this original Pythagorean identity and divide everything by cosine squared, I get tangent squared of x plus 1 equals secant squared of x. These three Pythagorean identities are some of the most useful that you'll use all through this year and in calculus. Last ones we have are cofunction identities. You may have noticed that the sine of pi over 6 is equal to 1/2, which is also equal to the cosine of pi over 3. Well, how are pi over 6 and pi over 3 related? Turns out that pi over 2 minus pi over 6 is pi over 3. So we can expand that to be a general formula, which says that the sine of pi over 2 minus x is the same thing as the cosine of plain old x. The cosine of pi over 2 minus x is equal to the sine of x. And the tangent of pi over 2 minus x is equal to the cotangent of x. We also have cofunction identities for secant and cosecant, and let's see. Yeah, that's pretty much it. All right, so let's do some examples. We're supposed to use the given values to evaluate the remaining trig functions. Well, here I have a positive value for tangent, a negative value for cosine. So what quadrant does that put us in? Cosine is negative and tangent is positive in the third quadrant. Well, what angle in the third quadrant has a tangent of root 3 over 3 and a cosine of negative root 3 over 2? The answer is 7 pi over 6. So the sine of x would be negative 1/2, and the cosecant of x would be negative 2, and so on and so on. You guys can get the rest of those, right? Okay, how about this one? Well, cosine of pi over 2 minus x. The cofunction of cosine is sine, so we're saying that the sine is 3, sine of x is 3 fifths, and the cosine is 4/5. So since they're both positive, we're in the first quadrant. Opposite over hypotenuse is 3/5, and adjacent over hypotenuse is 4/5. Once we get our triangles set up, it's easy to get the rest of the functions. Tangent of x is opposite over adjacent. Cosecant of x is reciprocal of sine, and so on and so on. Okay. Use the fundamental trigonometric identities to simplify the expression. There is more than one correct form of each answer. Well, remember that whenever I see something squared, I'm thinking, okay, probably Pythagorean identity. And it turns out that tangent squared of x plus 1 is secant squared of x. And the reciprocal of secant is cosine. So our final answer, cosine squared of x. And that's the point of using trig identities. We take something that looks kind of big and complicated, and we reduce it and simplify it to something that's real easy to work with. Let's do some more. Okay, so we've got a cotangent or cofunction question here. Cotangent is the cofunction of tangent. So we're going to replace cotangent of pi over 2 minus x with tangent of x. Now I'm going to use my quotient identities. I'm going to replace tangent with sine over cosine. And notice that the cosines will cancel. And we're left with sine of x. So this whole expression right here is exactly the same as writing sine of x. Got one more down here. Okay, whenever I have sines, cosines, and tangents mixed together, I usually convert my tangents to sine and cosine. Let's see what happens when we do that. Sine of beta, and I'm going to replace tangent with sine beta over cosine beta, and then add a cosine beta to that. Okay, nothing's canceling over here, but what would happen if we got a common denominator? In other words, what if I put that cosine beta over cosine beta? I would get sine squared beta, that's over cosine beta, plus cosine squared beta over cosine beta, and that gives us sine squared plus cosine squared all over cosine. And sine squared plus cosine squared should sound familiar. That's just 1. So I end up with 1 over cosine beta, which is the reciprocal of secant beta. Okay, now let's see if we can do some factoring and simplifying on these. I'm going to take a cosine squared out, leaving me with 1 plus tangent squared, and tangent squared is 1 plus tangent squared is secant squared. So I have cosine squared x times secant squared x. That's a Pythagorean identity. Well, cosine and secant are reciprocals, so guess what happens when you multiply reciprocals together? The whole thing equals 1. So this is 1. All right, let's factor this and see what happens. I'm going to do difference of two squares. So I'm going to have sine squared x minus cosine squared x times sine squared x plus cosine squared x. And sine plus cosine, sine squared plus cosine squared is 1. And so our final answer is sine squared minus cosine squared. It looks like we ought to be able to do something with a Pythagorean identity there, but we can't. That only works with sine squared plus cosine squared, not sine squared minus cosine squared. Here's one more. Whoop. Let me bring that up here where I can work with it. Okay, we're going to multiply this out. So it's going to be sine squared x plus 2 sine x cosine x. Remember, we've got to do FOIL on this. Plus cosine squared x. Now if I group these two together, they're going to equal 1. And so the only thing I have left is 1 plus 2 sine x cosine x. I've got one more here. About the only thing you can do right here is get a common denominator. So I'm going to multiply this one by 1 minus cosine x. I'm going to multiply this one by 1 plus cosine x. And I'll have the whole thing over this times that. So here we go. 1 minus cosine x plus 1 plus cosine x over 1 plus cosine x times 1 minus cosine x. On top, I have a negative cosine x and a positive cosine x, so they cancel. I've got 2. Underneath, I have the difference of 2 squares. And 1 minus cosine squared x by Pythagorean identity is sine squared x. And the reciprocal of sine is cosecant. So my final answer is 2 cosecant x. So that's it. If you have any questions, write them down and we'll go over them in class, and then we'll do some problems together.